Hi everybody. So tonight we're going to do section 1.3. Uh, and we're going to, in this video, we're going to do number four and then we're going to do number six. So let's start with number four. I'm going to switch to so we want a polynomial. Um, Now, since it's 3 points, that means a second degree polynomial. And so basically we want to find that's a parabola that goes through these 3 points. First of all, you don't have to be an Einstein to realize that these 3 points are all collinear. So our parabola is going to devolve into just a straight line. Um, but let's go through the process. Let's actually see that happen. So I'm going to go into my paper. So spoiler alert. I mean, just by looking at it, you could these are three. This is a horizontal line. I mean, so after we do this process, we better get the answer y=4. Otherwise, we're going to be a bunch of dummies. But I think that'll be fine, and it's still instructive to go through the process. So we're going to do it right. Let me just set up my camera. Okay, perfect. Hope you can all see. So I hope you can all see that. Yeah, it looks good. Okay. So we know that when x=2, y=4. So I know that a naught plus a1 times 2, otherwise known as 2a1, plus a2 times 2 squared, otherwise known as 4 a2, yeah, a1 2, is equal to y value is going to be 4. And when x is equal to 3, I have a naught plus 3a1, very similar. Okay. Okay, very similar process. This is my system of equations. Well, no, what I love about this problem is that the coefficients now become the variables. The coefficients of the polynomial become the variables in the system of linear equations, which is kind of cool. I don't know, I always feel the sort of irony in that. Um, where have we seen this sort of thing where coefficients are into variables? I'll let you think about that. Anyway, um, let's turn this into a matrix, and the matrix would be 1, 2, 4, 4, 1, 3, 9, 4, 4, 6. Okay, so the first thing we're going to do is subtract negative R1 plus R2 becomes new R2. Negative R1 plus R3 becomes new R3. And again, I want to turn these ones here I want to turn this first column into zeros. I mean, except for the top zero. So now they have 1, 2, 4, 4. I have, that's going to be there, that's going to be, okay. So I'm subtracting 2, okay, so that's going to be 1 and 2, that's subtracting 4, so that's 5 and 11. 11, right? 12, 5 and 12. And these are going to be zeros. And let's just let's just turn this 2 into a 0. So I'm going to subtract row 3. I'm going to subtract row 2 from row 3, and that's going to be my new row 3. Uh, and that's going to be 1, 2, 4, 5, 1, 1, 0, 1, 5, 0, and that's going to be I was subtracting 2 row 2. Sorry about that. I was subtracting 2 row 2. That turns into a 0. If I subtract 10, that becomes a 2. Then I subtract 0, it becomes a 0. And again, well, obviously, let's just turn that 2 into a 1. So 1/2 row 3 becomes a new row 3. And we now have 1, 2, 4, 4. And we have 0, 1, 5, 0, and 0, 0. And we we could let's make this a little bit simpler. I mean, I don't know if yeah, why not? We could do back substitution at this point, or we could do reduced row echelon form. Let's do in other words, we could stop the matrix stuff and now just and do back substitution. That's called Gaussian elimination. Or we could go put this into reduced row echelon form, meaning turn the 2, 4, and 5 into zeros, which I see is going to be pretty easy to do. And then that would be called Gauss-Jordan elimination. So whatever. Anyway, don't get confused with all the names. I'm going to subtract, let's see, 4. I'm going to do, let's see, row 1 minus 4, row 3. It becomes a new row 1. And row 2 minus 5, row 3 becomes a new row 2. And now I have, by the way, the writing it down is taking more time than actually doing it. But let's just 1, 2, 0, 4, 0, 1, 0, 0, 0, 0, 1, 0. And now finally, I can subtract row whatever. So it's negative. So row 1 minus 2 row 2 becomes the new row 1. And I finally have 1, 0, 0, 4. This basically tells you that x equals 4, y equals 0, and z equals 0. Actually, it's not x, y, z. It's a naught, a1. So this basically tells me that, excuse me, a naught equals 4, a1 equals a2 equals 0. So my polynomial p of x is just going to be 4. Which, like I said, that's y equals 4. And gee, what a shock. I mean, whatever y value, whatever x value I put in, I get a y value of 4. Wow. Boy, am I shocked. Like I say, this is a problem that we could easily see just by inspection. I mean, just by when I say inspection, I mean just kind of like by looking at the problem, I can see what the answer has to be. But nonetheless, I just want to demonstrate the process. Now I want to go to one that's not so obvious at all, and that's problem number 6. So yes, and I'm going to go to problem number. Let me just show you problem number 6 on the screen first. Let me share my screen. All right, so there's problem number 6. We wanted to go to those points right there. So now notice there's 1, 2, 3, 4, 4 points. So 4 points, that means a third degree polynomial, cubic equation. So let's get started here. So these are the points, and which I guess I should copy it. Let's just copy the points down. The paper 042. 10, and then 2, negative 40, and then 3, negative 3. Okay, let's go to now. Let's actually do this guy. So here's the points. It goes to these. It goes to these 4 points: 0, 1, 0, 2, 40, and 3, comma negative 72. Let me just confirm that. Let me just confirm that. So I want to double check. 0, 42, 1, 0, 2, negative 40, and yeah, okay. So good. I would hate to go through this whole long problem and find out that we, just put the wrong numbers in. It's me, but you know what I'm saying. Anyway, let's turn this sucker into a matrix and let's get zipping on this. So I'm actually I need a little more space for this. So I'm gonna put this. So this is my equations. I'm gonna, so we have. Let me just copy it. X plus A2 x squared plus a3 x cubed. That's the third degree equation. Third degree equations have four, coefficients in them. And now my matrix is going to be 1, 0, 0, 0, 42. And then 1, 1, 1, 1, 0. That means when x is 1, that's what I get here. And when x is, notice that this whole first column is going to be 1. So that's nice. And that's 1, 2, 3. This column is going to be 4, 9. And 8, 27. This is going to be 42, 0, negative 40, and negative 72. That's not a negative sign, that's just a... Okay, so we're going to do what we always do. We're going to do what we love doing. We're going to do what we're trained to do. I'm going to get rid of this paper. I don't need it so much anymore. I don't need the equations. We have the matrix now. The matrix. It's just getting in the way. Okay, so first I want to turn all these ones here into zeros. So negative row 1 plus row 2, negative row 1 plus row 3, and plus row 4 becomes the new row 2, the new row 3, and the new row 4. Okay, so we've got a whole bunch of subtracting to do. So my top stays the same, 1, 0, 0, 0, 42. And this is and we're gonna have a bunch of zeros here. And okay, and now subtracting, now this is gonna be very quick because I'm just subtracting zeros here. So all this stuff stays the same. 1, 1, 1, although that's not gonna stay the same. When I subtract 42 from 0, I get negative 42. Now that's gonna be 2, 4, 8. 42, so that's negative 82. And now that's going to stay 3, 9, 27. And negative 72 minus 42 is minus 114, minus 114. Okay, so I want to make my life a little bit easier. Now, basically, I want to do is I want to get rid of I want to use this one. I want to use this one here to knock off the 2 and the 3. I'm just thinking here, I don't know why, and it's not necessary. I'm going to do an extra step, which is I don't think it's necessary to do, but for some reason I find it easier. I don't know why. I don't know why I'm finding it easier. Is it really so easy? Yeah. What I was going to do is see small minds appreciates okay, small minds like mine like small numbers. So since the third row is all even numbers and the bottom row is all multiples of 3, I was going to multiply. I was going to divide. In other words, 1/2 row 3 would become the new row 3, and 1/3 row 4 become the new row 4. And for some reason, I don't know. I just find it a little easier. So I'm going to do that. You don't have to do it this way, but I just feel like it. As I said, small minds. Okay, so we have 0, 0, 0. So this guy's still the same. 1, 1, 1, and that's negative 42. This here is okay, so I'm dividing everything in half. So that's 1, 2, 4, 1, 2, 4, and that's negative 41. Then 3, 1, 3, 9, 1, 3, 9, and 114 divided by 3. Let's see, that's going to be 9. That's 3. And then with 24, so it's going to be 38. This is my new matrix. Now, instead of I don't know, this way I just multiply, I just subtract row 1, I'm sorry, negative row 2 plus row 3. is going to become the new row 3, and negative row 2 plus row 4 is going to become the new row 4. So let's put that all up here. Okay, so my top two rows aren't changing. I'm just going to copy them straight. 1, 0, 0, 0, 42, 0, 1, 1, 1, negative 42. Now I'm doing my subtracting. So these guys, so these two ones now just become those two zeros. Now I'm subtracting 1, so that becomes 1 and 2. And I'm subtracting 1 here, that becomes 3 and 8. And now I'm subtracting negative 42. So negative 42, so that becomes just positive 1. And I'm subtracting negative 42 from this, that becomes positive 4. And once again, I'm going to, well, I'm not gonna bother. I'm just gonna subtract I could divide the bottom row in half, but for some reason I'm not gonna bother. But like I say, it doesn't matter, just say, same thing. So I'm gonna do negative 2 times row 3 plus uh row 4 is gonna become the new row 4. And now I have 1, 0, 0, 0, 42, and 0, 1, 1, 1, negative 42, and 0, 0, 1, 3, 1. And finally, that's going to be 0, 0. That 2 now becomes a 0. Subtracting 6 now, so that's a 2. And I'm subtracting 2, so that's a 2. And, well, I guess I'm going to have to divide by half anyway. So 1/2 row 4 becomes the new row 4. And 1, 0, 0, 0, 42, and 0, 1, 1, 1, negative 42, and 0, 0, 1, 3, no, 0, 0, 1, and 0, 0, 0, 1, 1. Okay, so this tells me that uh, the last variable is A3. A3 equals 1. And it tells me that once A3 is 1, so A2 plus 3 equals 1. So A2 equals negative 2. And this tells me that A A1 plus A1 minus 2 plus 1 A A1 minus 2 plus 1 equals negative 42. So that's A1 minus 1. So A1 equals negative 41, right? Yeah. Negative 41. And without any hocus pocus, and I already know that A0 equals 42. We got that. So my new polynomial will, so my polynomial now is going to be, I don't know if I can get it all into one. Well, just, the polynomial is going to be p of x is going to equal 42 minus 41 uh, uh, x minus 2x squared plus x cubed. That's going to be my polynomial, because a naught. Why is that? Because a naught was 42, a1 was negative 41, a2 is negative 2, and is it Let's see here. So 40, yeah, okay. Let's check it out. Let's check if this polynomial actually, so obviously if P of 0 equals 42, so that's check. Let's look at P of 1. P of 1 is going to equal 42 minus 41 minus 2 plus 1. And that's basically 43 minus 43. So that equals 0. Check. Let's look at P of 2. P of 2 is going to be, excuse me, 42 uh, minus 2 times 41, which is minus 82, minus 4 times 2, which is minus 8, and then plus 8. So the 8's cancel. 42 minus 82 is equal to negative 40, and that's what it's supposed to equal, negative 40. So check. And P of 3, I guess. P of 3, what was my numbers? P of 3, that's P of 3. P of 3 is equal to 42 minus 41 times 3, which is minus 123, minus 2 times 9, which is minus 18, and then plus 27. So let's see, 42 plus 27 is 69, and 18 in there, that's 141. That's a negative 141, and you're going to subtract 69, and that becomes 13, and that becomes 11. 11 minus 9 is 2. Negative 13 minus 6 is 7, but it's negative, so it's negative 72. Check. All worked. So there you go. So we have a third degree equation. This is the you want to sketch the I think the problem is to sketch the graph, but I'll let you. That's high school algebra. You can figure out how to sketch a graph without me. Obviously the excuse me. Obviously the y-intercept is going to be 42. But you can figure it out with whatever methods you want. Probably the calculus, roughly sketch this graph. I'm not going to bother with that in this video. That's something you can figure out. I just wanted to do the linear algebra aspect. Anyway, this has been loads of fun, and this is a polynomial. I just want to say something, and I should have said this at the beginning. Polynomial curve fitting is extremely valuable in the world because basically, or not just polynomial curve fitting, but curve fitting in general. What does it mean? It means that we're taking. Um, I'm gonna put the camera on me now. I haven't done that in a long time. How do I do that? Oh, I'm gonna switch. I'm gonna talk to you like I'm actual. Can you see me now? Hi, can you see me? Um, so how curve fitting it has tremendous application like in business and in science because you want to take data and you want to find the best function, the best curve that fits that data. Because the idea is that we want to know what's going to happen. I don't know what these numbers are supposed to represent. It doesn't really say. But it could be how many bacteria there are. It could be money. It could be who knows what. But I want to know what's going to happen when I plug in 4. What's going to happen when I plug in 2.5? Well, if I could take these discrete points and find a curve that fits them nicely, I can use that to predict what's going to be in these other values. And predicting that's incredibly valuable. I mean, knowing the future, if you know the future, or if well, it depends on what you're trying to do. But if let's just say in business, if you know the future, you're like a millionaire. You know what I'm saying? Predict the stocks. You could predict how many, based on recent trends, how many widgets you should make. You don't, business. That's the thing. You want to make. I'm just saying in business, for example, you don't want to make too little because then you're going to be short. You get caught short-handed. You want to have the supply to the customers. You don't want to. You don't want to make too much because then you're stuck with all the leftovers. So you want to. I'm just this tiny example. The point is that this is a very very big topic. Well, that's it for this video. It's been loads of fun, and we'll see you guys next time. All right. Bye.